Hey everyone, welcome back to the Foundry by Forge College. Let's just jump right into today's explainer, shall we? So in our last lesson, we put together this incredibly detailed, frankly beautiful blueprint for our Solana deployment. But here's the harsh reality of engineering. A blueprint? It just sits there. It looks pretty on paper and it tells you what you want to build, but it absolutely does not build it for you. So today, we're making a massive pivot. We're transitioning away from those theoretical plans and diving into the actual physical machinery of deployment. We're going to build the engine that actually gets this done by designing an execution strategy.
To get us there, here is our roadmap for the explainer. First, we'll go from blueprint to action. Second, we'll break down the execution mechanics. Third, we'll look at the conveyor belt model. Fourth, real-world handoffs. And finally, we will wrap up with your capstone next steps.
All right, part one, blueprint to action, plan to reality.
So what's the actual difference here? Well, think of your blueprint as the ultimate definition of what success looks like at a high milestone level. It's the dream, right? It's kind of abstract, but your execution strategy, that is your concrete, step-by-step, actionable sequence. It answers two absolutely crucial questions. Exactly how do we get to that success, and who is specifically on the hook for verifying it? Because listen, without a solid execution strategy, your team is essentially flying blind. Responsibilities get muddy, and when you're dealing with a high-stakes Solana deployment, ambiguity is literally the fastest route to a completely failed launch. We definitely want to avoid that.
Moving on to part two, execution mechanics, 4 interlocking parts.
Okay, so our deployment machine basically runs on 4 interlocking gears. Gear number 1 is task sequencing. This is where we organize all our raw inputs into a strictly ordered list of dependencies. Gear 2 is roles and responsibilities, which means mapping every single task to a specific named owner. No mysteries there. Gear 3 involves validation gates. Think of these as the checkpoints that control the entire flow of the project. And finally, Gear 4 is acceptance criteria, which is the definitive proof that a step is actually done. When you snap these 4 components together, you completely eliminate that horrible, dreaded scenario where 2 engineers are just staring at each other saying, wait, I thought you were deploying the smart contract binaries. It replaces all that hopeful guessing with absolute, undeniable clarity.
Let's zoom in on that third gear for a second, a validation gate. This is a hard, non-negotiable decision point. It's a literal stop sign in your workflow that only turns green based on observable tests or physical artifacts. And here is the absolute golden rule for this. We do not, under any circumstances, move forward just because it happens to be 5 p.m. on a Friday and everyone wants to go to happy hour. Seriously, pushing code just because a date on the calendar arrived is a massive, massive failure mode in Web3. These gates guarantee that our progress is dictated strictly by readiness and quality, not the clock.
So how do we actually prove that readiness to whoever is guarding the gate? Well, that is exactly where acceptance criteria come in. Now, these have to be highly pragmatic, fully observable tests. If your deployment instructions say something super vague like, hey, just ensure performance is acceptable, you are basically begging for an argument. Like, what does acceptable even mean? Instead, we need objective, concrete evidence. Something like P99 latency is below 300 milliseconds under expected load. Boom. That is a hard, testable fact. And that's exactly the kind of proof that gives reviewers the absolute confidence to open up that gate and let you through.
Okay, section 3, the conveyor belt model, sequencing and validation.
For this part, I really want you to adopt a specific mental model. I want you to imagine your entire deployment process as a physical, factory conveyor belt. Your Solana artifacts, like your signed binaries, your infrastructure configs, the whole shebang, they are all moving down this belt. They kick off at phase 1, the build station. Once they're built, they roll right along to phase 2, the test station. Then they head down to the security station. And finally, they arrive at monitoring. And here is the kicker. At every single one of these stations, there is a strict gatekeeper inspecting the artifact. If it fails, the belt stops. Period. If it passes, a verification artifact is permanently attached to the record, and the whole thing just keeps rolling down the line.
Now, you might be wondering, doesn't that take forever? Well, keep in mind, not every single station on this conveyor belt needs to hit your artifact with a sledgehammer. We optimize this using a strategy called tiered validation. The idea is really simple. You want to run your fast, lightweight smoke tests as early as humanly possible. If your basic sanity checks fail, you want to know immediately, right? Then you save your really heavy, expensive, time-consuming load tests for the much later stages.
but only once you're absolutely confident that the foundation is rock solid. This tiered approach is a real game changer. It focuses your team's effort and maximizes risk reduction, all without causing massive traffic jams on your factory floor.
Moving right along to Section 4, real-world handoffs, explicit transitions. There's this golden rule in engineering that we always try to live by. Avoid passive handoffs where someone assumes another team will pick up a task. Come on, we have all lived through this disaster, haven't we? An engineer finishes their part, they update a branch, and then they just magically assume the security team is going to sense a disturbance in the force and somehow know it's their turn to do a review. Let me tell you, passive handoffs are exactly where deployments go to die. We have to design handoffs that are loud, they're clear, and they are incredibly explicit.
Let's break down what this actually looks like in a concrete deployment sequence. Step 1. The build engineer explicitly signs the binaries and leaves a tangible artifact behind. This could be an automated CI status, or even just a clear comment on a ticket. Step 2. The release engineer gets a formal notification. They go in and verify those exact signatures, and then they physically click an approval. Only after that highly explicit signal do we move to Step 3, where the DevOps engineer provisions the staging environment. You see, there are 0 dropped batons here, simply because every single transition leaves behind a verifiable artifact. It's foolproof.
To really bring order to all this chaos, you just need a minimalist mapping tool. It's basically a simple table where you map out the phase, the specific task, the accountable owner, the exact gate, and the measurable criteria. So, for example, let's say you have a canary deployed to staging. That task should be super clearly owned by the release engineer. It is guarded by a staging stability gate, and the criteria to pass is a strict uptime threshold. By structuring things exactly like this, you are taking those high-level, abstract blueprint milestones we talked about earlier, and you're converting them directly into accountable, everyday engineering work.
And that brings us to Section 5, Capstone Next Steps, Drafting Sequences.
All right, it is time to connect all this execution strategy directly to your capstone documentation project. I've got some highly actionable homework for you. First, I want you to draft a sequencing map for at least 2 of your critical milestones. Really get into the weeds here. List out the specific tasks and assign exact owners. Next, I need you to define those highly measurable acceptance criteria we talked about. And finally, bring those drafts to our next lesson. Being able to structure deployment logic this clearly is a staple of the learning programs we design at Forge College, mostly because it guarantees you're actually building the operational muscle you are going to need out there in the real world.
So I will leave you with this somewhat provocative question to chew on. What observable artifact will prove that your next deployment handoff is truly, actually complete? Is it going to be a signed checklist, a merged pull request, a test log? Whatever it is, do not rely on assumptions. Demand evidence. Thank you so much for joining me for this explainer. If you want to master these execution strategies and explore a huge range of other Web3-related topics, make absolutely sure to visit forge.college to learn more. Keep building, keep verifying, and I will see you in the next one.